we're going to watch the Smart AI Smart Village code for changes. So we need to run the following command in a terminal inside of VS Codes. I can open a terminal here. Terminal. Actually, I already have a few open, so let me close these. And let's see here. We're going to run this command here. We copy this to the clipboard and paste it in here. And this is configured to watch our Smart AI Smart Village project for code changes. But before it starts watching, it's going to re-index all of the Java classes to make sure it's up to date and that's all the details it needs. We also indexed all of the FIWARE Smart Data Models, and you can see here that it's guessing what smart data models we're working with, like crowd flow observed, parking access, traffic flow observed. So it's exactly right. It's integrated with those smart data models and doing its job. Now it says it's ready. So we're ready to start creating code. We're going to create a Java class called PhotovoltaicMeasurement.java. And then generate all of the code for it to represent a real smart data model. So photovoltaic measurement, let's just see what this is about. If we search for GitHub Smart Data Models, FIWARE, let's see. No, let's see. Photovoltaic measurement, green energy. Here it is right here. Photovoltaic measurement. This is what I'm talking about, smart data models. It's got examples and it's got a whole model defined in YAML to describe this smart data model. Fields like area served, which is a JSON coordinate for the device. What sounds interesting? Date, energy metering started. Inverter status, location, nominal peak power generation, reactive power. Interesting fields. I don't know a ton about it, but we're going to generate this smart data model. So continuing on, we create a directory, a source directory inside of Smart AI Smart Village, source main Java, or computate, Smart Village, ENUS model, photovoltaic measurement. And then we create a simple Java class with a package, a public class, and some curly braces, and we write it to the file. So let's do this. We select bash as our kernel. And if we look in Smart AI Smart Village, you'll see that in source, Java model, photovoltaic measurement, we now have this Java class here. Okay. So it looks like that. And let's update this one more time, and you should see some output in the terminal where it mentions photovoltaic measurement touched. See here, it wrote photovoltaic measurement touched. And you'll also notice that below that, it found 10 closest smart data model matches to our query. We wrote smart data model : photovoltaic measurement. Now let's see what the top result is. Well, the top result is called measurement inside of OCF smart sensoring. But what we were really looking for was photovoltaic measurement, which is all the way down here at number 10. So we can get better results with a better query. We can query for photo, space voltaic, space measurement, space green, space energy, space smart, space energy. Let's try this and see if it does a better job at guessing. Okay, look at that. It popped to number 1 with a score of 197, whereas before it had a score of 179. So that pops it to the top of the list. That's good. Now, if we remove this FIWARE :true, then it will generate some code for us. So what we do is update our class without that code comment, and you can see that it just generated a whole bunch of code for us. Let's take this code. It's a whole bunch of Java methods and comments for each of the fields in this smart data model. It's also got the imports that we need. So I copy this to the clipboard and go to photovoltaic measurement here in the application, and I'm going to replace all of this code here with the suggested code. And you'll notice that it's got a bunch of errors, but that's okay. They're going to resolve very soon. What it's going to do, if I go back down here, is generate, it says photovoltaic measurement page touched. It's generating a bunch of code for us, actually. If we go to source gen model photovoltaic measurement, here's the code that it's generating right now to help us. So it just resolved those imports. I'm going to add a space and then take it away. I'm going to save this one more time, and this should finish generating all the code that we need. So it was touched again, and let me show you up to the top here. We've told it to become a database model and build an API and a page and index it in the search engine, and give it a API URI of /API/photovoltaic measurement and a search page of /photovoltaic measurement. Now, let me open a terminal here. Oops. ls FIWARE Smart Village src main java org computate Smart Village in US model photovoltaic measurement. You'll see it's actually generated a whole bunch of APIs as well. Now I want this to refresh here. Let's see. For some reason it hasn't updated this code here, or let me think. Main source main java. Is this a refresh? Refresh Explorer. There we go. Okay, so now we got all of the generated API code. It's a whole bunch of complicated asynchronous reactive code to search for these photovoltaic measurements and ensure that we have the right access to this data, and we can get one value from the API. We can patch multiple values with this API. We can let's see. We can post new photovoltaic measurements to the API and import. So it's got a whole bunch of code to do all of that for us. It also has code to generate a page for us. And if you check FIWARE Smart Data static, it's generated JavaScript for us for photovoltaic measurement to query and update photovoltaic measurement values in the browser. It's also yeah, that's what it's done for static content so far. We're going to generate even more code here. So we copied that. We're going to rebuild the OpenAPI spec, the database scripts, and more. So a running web application is made up of much more than Java code. The Smart Village platform is also made up of CSS style sheets and JavaScript. Each model has its own set of specific JavaScript, specifics to its fields and APIs. An OpenAPI spec is generated to map out all of the APIs and pages in the site for system integrators to consume or update data in the site. And a database schema is also generated for storing all the model data with specific field values, tables, and foreign key relations. And the FIWARE Smart Village project also inherits certain static content from the parent project Smart Village platform, so that we can copy any updates to inherited static content into the project static content as well. And we also build a FIWARE context, which is documentation of all the FIWARE related smart data models following the standard for NGSI LD data, and publish the context to GitHub. So we run the command below to generate all of the code listed above. So it runs this Java code, and let's see here, we got an error. Let's see, class not found. Sometimes in this VS Code, it messes up the compiled Java packages. So let me go into the Smart Village platform and delete the target directory, and then maven clean install -d skip tests. In fact, that may have been what we needed to do earlier. Might have skipped a step or put it later on. So maybe I should do both of these here. Make this run better the next time. I'm going to put that there. So we're recompiling this. Although this kind of takes a while to run, so I'm just going to run it down here in the terminal. And then run the code generator up here once it's finished. Okay, build success. Let's try this again. So amazingly, we built thousands of lines of code, and they all compile. New code, it all compiles, and we regenerated the API spec. Take a look down here. It generated FIWARE context data for photovoltaic measurement, generated the model for us with all the same model data, the original model, and a little more. And it updated the, let's see, FIWARE Smart Village, source main resources. It updated the Open API spec, and the SQL create script now have photovoltaic measurement with all of the columns defined, active power with their corresponding types. So that's really useful for persistence. Now I'm going to add this in. Since this is a hackathon, let's make a quick update to this. Adding even clean install for generating open API spec. Push that up. Great. Now we're going to update the role-based access control defaults for photovoltaic measurement and register our new API. So we run this Ansible playbook, and it's going to update an application.yaml file, and it sets the auth role required for photovoltaic measurement to public. This means that users that have the role public given to them by the Red Hat single sign-on server will be able to create, update, view photovoltaic measurement records. And by default, that's going to be anybody with a GitHub account. So that was successful. And if you want to see the change that was made, you can see it here where it updated the application.yaml with the new photovoltaic measurement. And similarly, in the main vertical, it registers the photovoltaic measurement in US Gen API service. So that's good. We've already compiled. Actually, we're going to recompile the code because it's got updates to the main vertical. So we need to recompile the code here. After that, we're going to run the SQL scripts to create the new PostgreSQL database tables. Because when we create new smart data models that are persisted in the PostgreSQL database, we need to make sure that our database has all the tables and fields required to persist the data. We run the commands below to rsync the db-create.sql script I showed you earlier to the PostgreSQL pod. It will connect again and apply all of the database schema changes to the database. We just need it to finish compiling the latest code changes. And it's done. So we run this to rsync the db create, and it updates the data. So photovoltaic, It's not skipping. Here it is. It ran these updates to alter the table here, right here at the end. So that's good. And that's it. In the next video, we're going to run the application in development.